No. Okay, right? So, right. So I hope you all have seen the PDF what I have sent to you.
Yes, ma'am.
Okay. Right. So see, what we were studying till now, okay, in the circuits, what we have seen till now, right? The output at any given time, right, was depending on the inputs at that time. Okay, what we had seen. So we had seen what the combinational circuits, right? We had not seen the sequential circuits, right? We had gone through the combinational circuits. So, however, in a sequential circuit, right? What was the sequential circuit? The very first module, when we were starting, I told you the difference between combinational circuit and the sequential circuit. Okay. So, combinational circuit में क्या होता है? It does not depend on, yes, what was combinational circuit? Okay, I have to go back to the slide, I feel. See, the combinational logic circuit we had seen, it had no memory. You all can see the screen.
No, ma'am.
No, ma'am.
Huh.
Now, yes, ma'am.
Yes. Okay. So see, these were your combinational circuits where, see, the important is this. Okay, it had no memory, no timing, no feedback loops. Okay, their operation is instantaneous. These were your combinational circuit. When I talk about sequential circuit, see, the output values depend not only on the values currently being presented to its input, but also on the previous input values. Okay, so these are my sequential circuits. Okay, on these are my sequential circuits. So we classify these sequential circuit into synchronous sequential circuit and asynchronous sequential circuit. Okay, I hope you have heard about sequential and synchronous and asynchronous. Have you heard about synchronous and asynchronous?
Yes, ma'am.
Hmm? So yes, so synchronous is what? Synchronous. Okay, see, synchronous sequential circuits are the circuits in which you have something called as a clock. Okay, see, you all have studied electronics in first, second semester, right? In that you have studied the synchronous and asynchronous circuits, clocks. What do you mean by clocks? Right? Gated circuit. ये सब पढ़ा है ना? Have you studied this?
नो मैम, वो प्रमोट हुए थे।
तो क्या पढ़ा नहीं था? ध्यान नहीं दिया
याद
था.
है।
ओके. हाँ, ठीक है चलो. Okay, so देखो synchronous circuit, right? See, sequential circuits are classified. Okay, now you remember sequential circuits are the circuits in which output value not only depend on the present input but also it depends on the previous values. मतलब इसको memory रहता है. ओके अभी जो हमने सेकेंड मॉड्यूल तक किया ओके उसमें मेमोरी नहीं रहता है. थर्ड मॉड्यूल से जो कर रहे हैं ना हम लोग दीज आर माई सीक्वेंशियल सर्किट्स इनमें मेमोरी रहता है. So there are two types of sequential circuit. One is synchronous Sequential circuit matlab these circuits are controlled by a clock pulse, and there is asynchronous sequential circuit which is not having the clock pulse. Okay, now we'll go back to the PDF. Okay, right? So the very first basic memory element, right, what we talk about in a sequential circuit are my flip flops. Okay, this is the very basic memory element in the sequential circuit. Okay, so flip flop is a sequential circuit which can store either 1 or 0. Okay, it can store either 1 or 0 indefinitely, right, in one of these two stable states until there is any change promoted by the required changing. Okay, if अगर input change किया, right, until and unless you change the input इसमें कुछ भी नहीं होगा. Flip flop will store the memory. समझ में आ रहा है flip flop का मतलब? Understanding what is meant by flip flop?
Yes, ma'am.
Okay, right. So first we will see the basic bistable element. Okay, so this is how a basic bistable element looks like. Okay, see the circuit which can indefinitely store a 1 or a 0, right? So this circuit can indefinitely store a 1 or a 0. Okay, so let me explain you the working of this, right? However, I've written here, but you this operation. Okay, right. So it is this. Okay, now let us assume here initially, okay, let us assume that when the power is switched on, okay, abhi idhar power is switched on, that time let me assume that A is equal to 1. Okay, let me first assume, first case, let me say A is equal to 1. Okay, now when A is equal to 1, see this is my case 1, right? Let me say case 1. Okay, case 1 is what? My small a is equal to 1. Okay, my a is equal to 1. It means what would be a bar? See here, if a is equal to 1, इधर अगर a is equal to 1 है, yes, what would be a bar? See है, inverter है इधर. Hmm.
1, ma'am.
नहीं, a 1 है. See, a is 1 and it is coming to this inverter. What would be a bar?
0.
Ah, it is 0. Okay. Now, when your a bar is 0, what would be b? See, a bar से feedback आ रहा है b को. So, what would be b? You are understanding or no?
Ma'am, 0.
0.
Ah, see, if your a is equal to 1, a bar would be 0. It means our q is 0. It means our small b is 0. It means b dash is
1.
b dash is 1. It means q bar is, sorry, q bar is also 1. See this. Trace the circuit first. समझ में आ रहा है?
Yes, ma'am.
Okay. See, first what I have assumed, let a is equal to 1. So जब भी a 1 होगा, Okay, I'll use highlighter. Okay, here my A is 1, right? So when my A is 1, that signal A is going through the inverter and giving you A bar as 0. So A bar is 0 means my Q is 0. This A bar is coming from this line and coming to this B. So my B is 0. This B is going through a NOT gate and you are getting B bar. It means B bar becomes 1. Since B bar is 1, Q bar is 1. समझ में आया अभी?
Yes, ma'am.
Everyone understood the case 1?
Yes, ma'am.
Yes, ma'am.
So if I am talking about case 1, right? The circuit continues in this state until power to the circuit is switched off. Matlab, this, see, initially I had assumed A is equal to 1. The output will continue in this state only until and unless I make A is equal to 0. Okay, until the power is switched off. Okay, so this is one of the two stable states. Okay, so this is one of the two stable states. See, that's the same thing I have written here. Okay. See, when power is switched on to the circuit, input A is at 1. Therefore, see, here A is at 1. So A bar is 0. So Q is 0. A bar is given to input B, which is 0. It gets inverted, gives you 1. So Q bar is 1. Right. Therefore, Q is equal to 0 and Q bar is 1. Right. And the circuit continues in this state until power to the circuit is switched off. Right, it means until unless I make A is equal to 0, I will have Q is equal to 0 and Q bar is equal to 1. ठीक है, समझ में आया? Up till here is that understood?
Yes, ma'am.
Okay, right. Now similarly I'll take the next case. I'll take case 2. So here, now let me take here, earlier I had taken A is equal to 1. Now I'll take A is equal to 0. When A is equal to 0, A bar becomes 1, Q becomes 1, B becomes 1. So B bar becomes 0, Q bar becomes 0. Any issues up till here? Any issues up till here?
No, ma'am.
No. So see,
No, ma'am.
okay, right? So see, when A is equal to 1, your Q was 0, Q bar was 1. When A is equal to 0, your Q is 1 and Q bar is 0. Okay, so these two are my stable states. Okay, these two are my stable state, and the circuit will again continue to be in the case 2 until and unless the input is changed. Right, here case 2 किसके लिए आया? When my input is 0, A is equal to 0. Case 1 is when my A is equal to 1. Right, so these two are my stable states. Okay, see, this is the another bistable state of the circuit in which it definitely remains until and unless power to the circuit is again switched off, right? Or I change the power. Is it understood up till here?
Yes,
Have you
ma'am.
understood these two cases? These two cases are clear?
Yes,
Yes,
ma'am.
ma'am.
Okay, good. Now, see, the 1 or the 0 stored in the basic bistable element is called the state of the element. Okay, whatever is stored, Q bar, this represent the state of the element. It is said to be in one state when it stores a 1. It means when Q is equal to 1. And it is said to be in the 0 state when it stores a 0. Okay, when Q is equal to 0. Right. So besides these two stable states, right, these two are stable states. Either you will get Q is equal to 1 at what time you have Q bar equal to 0. Else Q is equal to 0, that time my Q bar will be 1. Okay, these two are my stable states. Apart from these two stable states, right, The bistable element can also be in a metastable state, which happens when both the outputs are midway between 0 and 1 in terms of voltage, right? It means midway. See, if I talk about a switch, switch will be either on or switch will be either off. Okay? So the bistable element can read either 0 or 1. 0 और 1 के बीच में कुछ भी वोल्टेज आया, bistable element cannot read it. समझ में आ रहा है? Are you understanding?
Yes, ma'am.
Hmm? So, see, that state between 0 and 1 is called as a metastable state. Okay, the state between 0 and 1 is called as a metastable state, right? So, when when the circuit or this bistable element, right, is going into metastable state, right? See, there is no mechanism. If we see this figure, okay, according to this figure, which is the figure for basic bistable element, right? There is no mechanism by which the basic bistable element can be forced to a desired state. Desired state means either Q is equal to 0 or 1. Okay, so there is no mechanism according to this figure when I can push my circuit to a desired state, right? So to get that desired state, we need to add input lines which can be used to change the state of the bistable element. Okay, so we need to add the input lines which can be used, right? See here what happens, I have control only on A. Okay, see again, once you assume A, the output goes on continuing. ठीक है, I cannot change the output because it's a total feedback. ठीक है, तो कंट्रोल करने के लिए आई वांट एडिशनल इनपुट लाइन. Okay, I need additional input line, right? So see, we need to add an input line which can be used to change the state of the bistable element, right? So therefore, a flip-flop is a bistable circuit with input lines. Okay, now we'll see all about the flip-flops. Okay, so a flip-flop is a bistable circuit with the input lines. The flip-flop remains in one of its two stable states, Q is equal to 1 and 0, until power is switched off or until an input signal triggers a change in the state. Up till here, is it understood? Up till here?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Okay, right? Now, a flip-flop is said to be set or preset when input signal causes it to store a 1. So, if your flip-flop is storing 1, it is said to be in the set state. If your flip-flop is storing a 0, it is called to be in the reset state. Right? Set or reset. If my flip-flop is storing 1, it is said to be set. If it is storing 0, it is said to be in the reset. Okay. So the inputs to the flip-flop could be either synchronous or asynchronous. Right? I told you either clocked one or I won't provide a clock. Okay. So the flip-flop changes its state immediately in response to appropriate changes in its asynchronous inputs. It means I'm giving the inputs. Inputs are not synchronized. Okay, inputs can be asynchronous. It need not be 1 1. It can be 1 0, right? The flip flop changes its state immediately in response to appropriate changes in the inputs what you are giving. That is why it's called as a flip flop. Okay, see, flip flop is a basic modification over this bistable circuit. Okay, wherein I cannot change the input once it is given. Okay, so on the other hand, a synchronous input can only affect a change of a state at certain times with reference to a clock. I told you Synchronous circuits are the circuits which are having the master clock, okay, such as on the rising edge of a clock. Okay, you all are aware of clock pulse? Are you all aware of a clock pulse? How it looks like? How we represent a clock pulse?
No, ma'am.
Okay, see, if I show you the timing diagram, right? I'm showing you a timing diagram and I assume that this is a pulse. Okay, this is a timing diagram. This is a, say, voltage axis. Let me say this is timing axis. So what you see here is a voltage pulse, okay? And this is called as the rising edge. This is called as a falling edge, okay? So my synchronous circuit can react to this rising edge also. समझ में आया? It need not be here. My synchronous circuit will, it is not giving you a delay to work here. Even at the rising edge, it is giving you variation in the output results. समझ में आ रहा है? What do I mean by this? See? On the other hand, a synchronous input can only effect a change of the state at certain times with reference to a clock, such as on the rising edge of the clock. Right? समझ में आया? Understood this diagram? Yes or no?
No, ma'am.
Yes, ma'am.
Ma'am, please repeat once again, ma'am.
Okay. See, if I draw a timing diagram, okay, let me draw a timing diagram. Let me take this as voltage axis. Let me take this as a time axis. ठीक है? अगर मैं एक वोल्टेज का पल्स बनाती हूँ, it will be like this. ये पता है तुमको? वोल्टेज वेवफॉर्म.
Yes,
Okay.
ma'am.
हाँ, तो this is a pulse. You all understand what is a pulse?
Yes, ma'am.
हाँ, pulse is like this. These are my pulses. ठीक है? So generally we call as a clock pulse. ठीक है? इसको हम लोग clock pulse बोलते हैं. So इसका जो ये edge है ना, इसको rising edge बोलते हैं. इसको falling edge बोलते हैं. ठीक है? So my synchronous circuits operate as soon as you give the clock pulse at the rising edge of the clock pulse. समझ में आ रहा है? टाइम डिले नहीं होता है. सी, अगर तुमने T1 पे दिया क्लॉक पल्स, ओके, it does not make any sense that your circuit is starting to work at T2. Then it will give you a delay of T2 minus T1. इतना टाइम डिले देगा वो तुम्हारा सर्किट. समझ में आया?
Yes, ma'am.
Huh? So my synchronous circuits work on this rising edge of the clock pulse. Okay. So exactly at T1. Right. So these are my synchronous circuits. अभी समझ में आया?
Yes, ma'am.
Yes, ma'am.
Okay. So any changes in the inputs between two rising edges goes unrecognized in a synchronous input, right? Now, synchronous flip-flop will have enable or clock inputs in addition to the inputs used to cause a change in the state, right? So initially I told you synchronous flip-flops will have the clocks, right? That is why these are called as flip-flops, okay? Now, the latches is one of the class of flip-flop whose output responds immediately to appropriate changes in the input in spite of the presence of an enable or a clock input. Okay, so latch is one type of flip-flop. Okay, so flip-flop are basically my memory elements, right, which can indefinitely store a data, giving an advantage of having an input, and that is why you can have a control on the output state. Okay, So in that, the first one is a latch. Latch is a class of flip-flop whose output responds immediately to appropriate changes in the input in spite of presence of an enable or a clock input, right? So there are several types of latches based on the types of inputs and the enable lines, right? So first latch we will see is the SR latch, right? Is it understood up till here? अभी
Yes,
तक
ma'am.
क्या बोला समझ में आया?
Yes. Yes, ma'am.
Okay, right? So the first type of latch we will see is the SR latch. Okay, we'll see the SR latch. So my SR latch stands for set reset latch. Okay, SR stands for set reset latch. So here, if see set means what? Set में my Q will be equal to 1. Okay, see this is
मैम
how
स्क्रीन में दिख रहा है.
नहीं दिख रहा है?
नहीं मैम.
No, ma'am.
हाँ अभी दिख रहा है मैम.
हाँ, okay. So see, this is how a basic SR latch looks like. ठीक है? Where S stands for set, R stands for reset. Okay? See, the two NOR gates are cross coupled in order to configure a SR latch. Okay? So this figure is a basic SR latch where I have used two NOR gates which are having cross coupling. Okay? Cross coupled in order to configure a SR latch. The S and R stand for set and reset inputs of the latch, while Q and Q bar are the two outputs. Okay, so Q and Q bar are two outputs and they represent the state of the latch when the inputs are applied. It means present state. Okay, Q bar. समझ में आ रहा है? Q bar. As soon as you give the input, what is the output? That is my Q bar. Okay, मतलब nth state, not n plus 1 state. समझ में आ रहा है? So here this is SR latch with OR and inverters. The same SR latch I have modified. This is a NOR gate and this is a OR gate with inverter. Okay? ये दो डायग्राम क्लियर है? समझ में आ रहा है ये दो डायग्राम?
Yes, ma'am.
Okay. ठीक है? Now you can see this is a symbol of SR latch. Okay? S, R are my inputs, Q and Q bar are my outputs. This is another way of representing SR latch. S and R inputs, Q and Q bar. See, I have put a note. So Q and Q bar are my two outputs. Right? And this is my truth table. Okay, so let me explain you the SR latch, how it works. This is my SR latch. So I'll put a truth table here. Okay, so in truth table, what all I am putting here? I am substituting the two inputs S and R. Okay, and I am substituting two outputs. See what I have done here. My two inputs are S and R. Okay, S and R are my two inputs. However, see, Q and Q bar. See, इसमें feedback loop है, right? This is a feedback loop. Okay. It means whatever input you are getting at Q is being given to S here, this one, right? Whatever you are getting Q bar is given to this first NOR gate. ठीक है? Where your outputs are Q and Q bar. इसका जो next output होगा ना, that I am taking as Q plus and Q plus star. समझ में आया what is Q plus and Q plus star? Understanding what is Q plus and Q plus star?
मैम रिपीट.
See, Q and Q bar क्या है मेरा? Whatever I give the input, okay, initially let me assume R is equal to 1, R is equal to 0, S equal to 0. ठीक है? R is equal to, I will put it here. Okay, now see, when my R is equal to 0 and S is equal to 0. Okay, when my R is equal to 0, S equal to 0. What would be my Q? Huh? What would be my Q?
1.
How? See, इसके लिए पहले Q assume करना पड़ेगा. See, because if you see here, this is a NOR gate with two inputs. I have only said that initially R is 0 and S is 0. But I do not know this input. This input I'll come to know only when I get this output Q bar. This output Q bar I'll come to know only when I come to know what is this output Q. So if I assume that initially Q is also 0 and Q bar is also 0, or if Q is 0, Q bar 1 will be 1. Agree? So see, if your R is 0 and Q bar is 1, 1, 0, NOR gate 1 plus 0, output is 0, so your Q will be 0. समझ में आ रहा है कि नहीं आ रहा है?
Yes, ma'am. Yes, ma'am.
हाँ. So what I mean is, initially I am assuming some value of Q and Q bar. समझ में आया? So initially I am assuming Q is equal to 0 and Q bar is equal to 1. ठीक है? ये मेरा initial assumption है. Okay? So depending on initial assumption, see, when your Q is equal to 0, Q output is acting as next input to second NOR gate. So 0 plus 0 is 0. उसका not किया तो 1. So Q bar I am getting 1. So मेरा next state में भी I am getting Q bar is equal to 1. अभी ये 1 वापस जाएगा R को, here, sorry, first NOR gate को. 1 plus 0 gives you 1. 1 का not होगा 1. करेक्ट है? सॉरी, 1 का not होगा 0. करेक्ट है?
Yes, ma'am.
यहाँ तक समझ में आया?
Yes, ma'am.
हाँ. तो ये पहले वाला स्टेट मेरा Q स्टेट था. ये जो नेक्स्ट स्टेट आया ना, ये मेरा Q प्लस स्टेट है. अभी समझ में आया? What is Q and Q plus here? See, Q denotes the present state of the latch. Okay, Q denotes present state of the latch, while the Q plus and Q plus bar are the response of the output to the applied input. Right? So Q plus denotes the next state of the latch. समझ में आ रहा है? What is this truth table now?
Yes, ma'am.
Okay, so this is what how is my truth table. But now we have to construct the truth table for row number 0, 1, 2, 3 for the combination 0, 0, 0, 1, 1, 1, 0 and 1, 1. Okay, for these combinations we will be constructing the truth table for the SR latch. So I'll come back here. Okay, right? Let me say that is your first NOR gate and this is my second NOR gate. For the condition R is equal to 0, S is equal to 0, okay? See, see, for this first condition we are simulating now, okay? R is equal to 0, S is equal to 0. Now initially what I said, we have to assume Q as 0 and Q as 1. ओके दोनों केस के लिए देखना है. समझ में आ रहा है क्या बोल रही है मैडम?
मतलब क्यू प्लस में क्यू प्लस नॉट के लिए ये करना है ना मैम?
अभी ये तुम्हारा नेक्स्ट स्टेट है. क्यू प्लस बार हमारा नेक्स्ट स्टेट है. क्यू एंड क्यू बार जो है प्रेजेंट स्टेट है. सो अभी प्रेजेंट स्टेट हमको अज्यूम करना है 0, राइट? अगर क्यू 0 हुआ तो क्यू बार 1 होगा. सी 0 एंड 1 है ना, एजम्पशन है हमारा. समझ में आ रहा है? 0 एंड 1 क्यू अजम्पशन है हमारा. इंस्टेड ऑफ 0 एंड 1 इट कैन बी 1 एंड 0 ऑल्सो. क्यू 0 भी हो सकता है, 1 भी हो सकता है ना.
यस मैम.
हाँ, तो पहले हम लोग 0 के लिए एनालाइज करते हैं. When your both inputs R and S are 0, 0, let us see how my Q plus and Q plus bar react when I assume Q is equal to 0. Now, am I clear?
यस मैम.
So now, when my Q is 0, obviously Q bar is 1. Okay, so my Q is, I'm assuming 0. It implies my Q bar will be equal to 1. Okay. इधर कॉमा डालती हूँ मैं. ओके, नेक्स्ट स्टेट के लिए क्यू बार इधर कॉमा डालती हूँ. नाउ सी क्यू इज 0. ओके, दिस 0 इज कमिंग टू दिस, राइट? सो 0, 0 would be 0, output is 1, so q bar plus will be 1. This 1 comes back to this. 1 plus 0 is 1. Not okay, I'll get 0. So Q plus will be 0. समझ में आया? This point, is it understood? Yes or no?
Yes, ma'am.
So हमने क्या किया इधर? Here, initially I assumed Q is 0 and Q plus also I got it 0. Agree or no? Do you agree?
यस मैम.
हमने जो अज्यूम किया क्यू बार भी सेम आया एंड क्यू सॉरी क्यू प्लस भी सेम आया और क्यू प्लस बार भी सेम आया. ठीक है, ये मेरा फर्स्ट एजम्पशन था जब मेरा Q 0 था. ठीक है, नाउ व्हाट आई विल डू, आई विल अज्यूम माय Q इज 1. I'll assume my Q is 1. It means मेरा Q bar क्या हुआ 0. Okay. Now when your Q is 1, see 1 comes from here. It comes to this. 1 plus 0 gives me 1. उसका not हुआ 0. This 0 comes here, comes to NOR gate 1. Right? This is 0. 0 plus 0 is 0. Not okay, I got 1. So did I again get same what I had assumed?
Yes, ma'am.
Okay. So it means what? So see here also I got it as 0 and 1. So what I'll do, instead of doing this, what I'll write here in Q plus and Q plus bar, I say that I had got Q and Q bar. Is it okay? Or I can write here that I had as restored previous state. Is that okay, or are you getting confused here? See, confusion है कि समझ में आया मैंने क्या लिखा है इधर?
समझ में है मैम.
Okay, so see, for S and R being 0 0, I get whatever was there in my previous state. Okay, previous state Q and Q bar. Q and condition. Second case, now I'll consider this second one. S is 0 and R is 1. Okay, I'll check for S0, R1. So what I'll do here, now I'll make S0 and R1, right? Again, 2 times I will analyze my Q. Initially when Q is 1, when Q is 1, my Q bar is 0. Okay, abhi I'll analyze. See, when your Q is 1, this 1 is coming here, it is coming here. 1 plus 0 is 1. Okay, 1 plus 0 is 1. Not okay, you are getting 0. Correct? Now, समझ में आ रहा है? You are understanding?
Yes, ma'am.
Hmm? Now see, this 0 will come here, right? Now, 0 plus Okay, should I explain once again, or have you understood this 0, 1?
Ma'am, understood.
Okay. All of you have understood it? How I got 0, 1 here? Rajat? ऋतिक?
यस मैम।
समझ गया कैसे आया?
थोड़ा कंफ्यूज हो रहा है, बाद में वापस ट्राई करूँगा।
Okay. Others, anyone wants me to explain this? Or should I proceed for the next step?
Yes.
Explain?
Ma'am, explain 1 second, ma'am. 1 second, ma'am.
Okay. Right. So here, see, ये first वाला तो I hope everyone understood, right? First one, how I retain previous state. This is clear, right? Now I'll check for s is equal to 0 and r is equal to 1. Okay. Now here I'll take s is equal to 0 and r is equal to 1. So to get the output, first I have to assume. Okay. So first let me assume that q is 0. Okay. So when your q is 0, right, what happens? See, this 0 comes from here. It comes here. Okay. So 0 plus 0 क्या हुआ? 0. Not होके तेको आया 1. Right. So it was obvious कि अगर q 0 हुआ तो q bar तो 1 ही होगा. Now this one comes here, comes here, comes here and comes to this. Okay. So ये 1. Okay. 1 plus 1 gives you 1. उसका not किया तो you will get 0. Okay. So what I had assumed is correct. Okay. This is the first case when r is 1 and s is equal to 0. See, when r is 1 and s is equal to 0, you get q plus as 0 and q plus bar as 1. Okay. However, the second case is, the second case here is I assume the say r and s to be same. Okay, I assume r to be 1 and s to be 0. This time I'll assume q to be 1. ठीक है, तो q 1 assume किया, तो see 1, it's coming by this way. 1 plus 0 is 1. Not किया तो I'm getting 0. That 0 is coming here and it is coming back here. So 0 plus 1 gives me 1. Output of NOT gate is 0. This 0 is coming back here. It's coming here. 0 plus 0 is 0. Not okay. Next state I get 1. अभी समझ में आया? Now is that understood?
Yes, ma'am.
So see, this was my previous state. पहले का स्टेट था ना ये q बार. अभी का स्टेट कितना है? q plus and q plus bar. So here q plus and q plus bar, when s is equal to 0 and r is equal to 1, I get 0 and 1. See, for s is equal to 0 and r is equal to 1, I get 0 and 1. Same, 0 and 1. समझ गए यहाँ तक? समझ गए यहाँ तक अभी? So for s is equal to 0, I get q plus 0 and q plus bar as 1. Right? I hope this is understood now. Now, अभी third state 1 0 के लिए 1 0. Again, same case you have to do. 1 0 means S is 1 and R is 0. So I'll write here, right? S is 1, R is 0. First I'll assume Q is 0. Okay. So see, 0 comes here, it comes, here it comes, here it comes. 0 plus 1 is 1. 1 ka not was 0. See, 0 comes here. You all are here?
Yes, ma'am.
Hmm? So see,
Yes, ma'am.
0 I have taken here and I'll assume here this is 0. So that 0 comes here and travels here.
मैम आपका माइक म्यूटेड है.
Oh, yeah. Okay. Right? So, see, there is no issues in doing these two. ठीक है? इन दोनों का प्रॉब्लम नहीं आएगा तुमको. Right? Problem is for the metastable state which gives me 1 1. Okay, which I see or which the flip-flop sees when it sees both inputs are high. ठीक है? So here in this, if I say both inputs are high, okay, now here अगर दोनों S दोनों 1 करती हूँ मैं, here if I make S also 1 and R also 1, okay, इसमें क्या होगा, if I assume initially this to be 0, okay, now see this will come here, okay, 0 1 1 1 not 0, 0 1 1 1 का not होगा 0, again that 0 will come here, okay, so the states will go on repeating itself. समझ में आ रहा है ना, 0 आएगा 1 आएगा 0 आएगा 1 आएगा. So the flip flop gets confused in this case. So this case when the flip flop encounters the S and R both to be high, okay, S and R both to be high, this state is called, okay, this state is called as forbidden state. Okay, so this state is called as forbidden state, right? So there are this is forbidden state or that metastable state. Okay, so there are three different states of an SR latch. One which gives you previous state Q and Q plus, sorry, Q and Q bar. One which would be same as your SR. If your S is 0, your Q is 0. If your S is 1, your Q is 1. If your S is 0, your Q plus bar will be 1. Or reset is 1 means Q plus bar will be 1. And your reset is 0, Q plus bar will be 0. This is the second state. Means these are my stable states. 0 or 1, 1 or 0 are my stable states. When both the inputs are high simultaneously, the flip-flop is said to be in the forbidden state. समझ में आ रहा है? फ्लिप फ्लॉप इज सेड टू बी इन द फॉरबिडन स्टेट. सो इस स्टेट में क्या करना है? आई हैव टू चेंज द इनपुट ओनली. Okay, because this is the same case as that of this bistable element. Okay, so bistable element का drawback क्या था? इनपुट ऐड नहीं कर पा रहे थे हम लोग, इसीलिए फ्लिप फ्लॉप डेवलप किया. सो फ्लिप फ्लॉप में जब ये फॉरबिडन स्टेट आएगा तो आई हैव ओनली ऑप्शन ऑफ चेंजिंग दिस इनपुट to either 1 or 0. Right? Understood this one? Everyone?
Yes. Yes, ma'am.
So you can go through the PDF. Okay? So up till here, you just go through the truth table. You go through this diagram. Okay? We'll continue in the next class with the next part of the same SR latch, where we'll see what is a debouncer circuit. Okay? So जो आज किया समझ में आया? SR latch, was it understood? Everyone? See here, I have written,
Yes, ma'am.
if you are here I have written S and R are 0, it means my present output is same as my previous output. Okay, and for 1 1 it is a forbidden state for the SR latch. Okay, so we'll quit for today. We'll meet tomorrow at the same time. Okay, so you all can quit the meeting for now.